This is where everything was made. Room number 278 in Comp Engineering Department. And thank you, Dr. Osme, for providing us this room. And now we're going to introduce you to our development areas. And he is Pavel Lyubich, C# expert, and he'll introduce me in a little bit.
Please, welcome to the lab.
So there are these past projects right here: a car, microprocessors, and a voice-activated bartender, and a walking robot. And now we're going to introduce you to our last semester's project. It's this car. It will reach destinations automatically, and there's a digital remote control. And he's going to toggle the lights right now. And as we see, the lights are off now. And let's turn on just for fun. And it avoids obstacles by itself. And we're gonna provide a demo of this when we finish our next version of the car.
This is Preet Kang. He's an expert in microcontrollers, and he's going to show the process that took from converting the original car wire wrapping protoboard to the PCB.
So this was our old microcontrollers. We used 2 of them. Provides more resources than what we really need. But back then, we didn't know as much as we know now. So we went ahead and switched these with the smaller microcontrollers. The resources are just perfect for what we're doing. And there's still 2 of them, because one needs to do Bluetooth algorithms, GPS algorithms, and provide control signals. And the way we program is we just put the chip here on this programming board, STK 500, and we program through a serial port, and this is a USB to serial cable. And this semester what we did is put everything on a PCB. So the PCB process is like this. So this is Eagle. It's a free PCB editor up to a certain size. I think it's 6 inches by 6 inches. PCBs are free. So this is the layout of all the components, how everything is connected. You have the footprints of all the microcontrollers, the 74LS logic chips, and a few other things. And once everything is laid out, we switch the PCB to the PCB editor, and we place the components in, and we did auto route, which routed all the wires for us. And once this is ready, we ship this off to a company that creates the PCBs. And now we're gonna go over to see what is the exact process of getting a PCB. So now we're going to introduce how we ended up to the final PCB. So
the first thing that we did was we ordered our first prototyping board, which is a little bit bigger than the actual final prototype. It doesn't have any silk screening or solder mask for the testing purposes. It does include 2 microcontrollers and all the ports for the sensors and the lights and the motor controls. And it's a little big, but this was the first prototype. Then when we tested it out and made some changes to it, we redid some of the parts on the board and came up with the design on the right, which is a much smaller version of the first prototype. This one does have the silk screening and solder mask. As you can see, all the components are labeled and all the wires are covered. Therefore, no interference or no scratching can occur.
And this is the red solder mask, so that's why the board is red.
So using some of these components that you see here, they're all get soldered onto the board, and the final product looks something that's over here. This board, as you can see, has 2 microcontrollers, a GPS port, Bluetooth port. It does have a program on board, so you don't have to take off the chips physically from the board to program it. And the GPS is almost the size of the quarter, and the whole design is not bigger than a regular dollar bill.
It's in the development areas. And now we're going to show you the heart of this RC car. The wires are no longer soldered in. The wires are no longer wire wrapped, and instead what we are doing this semester is putting everything on a PCB. Can you introduce this PCB?
This is GPS driver microcontroller PCB. Includes 2 microcontrollers that control the car. One microcontroller's function is specifically dedicated for the motor works, and the other microcontroller's function is dedicated for the GPS algorithms. The car connects to an application which is written in C# via the Bluetooth module. The new version of the GPS is much smaller and provides around 5 samples per second. The car is controlled by the PWM signals, which attach from the remote controls, original remote controls speed controller to the car. And where's this? Where's it? Right here. Just like so.
So being engineers, it's not all about coding. It's about making the entire product as a whole, and it involves getting dirty with the wires and making ribbon cables for the sensors and everything little leading to everything big. So what Pavel is doing right now is creating some sensor wires so we can plug in the sensors and plug them out, and yet make it solid enough that if there are bumps or anything while the car is running, it doesn't loosen up the wires and fails. So here he's created one side of the cable already, and the second side will get connected to the PCB. And here we have it, 2 sensor wires and a sensor right there which the wire plugs into. In this case, this plugs into a socket that gets soldered in the PCB, so you can plug it out and plug it in very easily.
Perform an initial sensor testing.
Take one. Ready? Triggering too fast. Oh, it's working. Front.
So cover up there. Hold on. Hold on. Okay.
Right now we only hooked the front, and the front's
Let's hook
working.
up all the other ones.
So what are you about to do?
We're about to run the car in free mode and see how well it avoids the boxes in the front.
Okay. So each time Pavel sends something, the lights flash. And now we're about to go back.
By clicking on Clark here, then I'm going to click here to set the destination. It calculates the dynamic path here, which is going to go through the Burger King fountains, and then it's going to go to Clark. Then we're going to go here, going to put the car into the GPS mode, and select run, and see what it does.
Trying to go to Burger King right now. I think we're too slow for the car. So we'll make a temporary stop at Burger King, and you won't actually feel it stop. It'll actually slow down, make sure it reaches Burger King before it goes to Clark.
Slow down.
And slow down, that means it made it to Burger King. Now it's trying to go to Clark.
29.
How many feet left?
130.
So 130 feet left
Feet
to
left.
Clark, and Clark in the middle of these two palm trees, and that's right by the bench.
40 feet. 20 feet, just stop now. There we go.
And there we go.
Destination accomplished.
Yes. Hold on. Now I'm gonna catch up with the car. Stop the camera for a little. Okay, go.
First we have a connection tab. This is where we choose where the Bluetooth is paired to, the COM port, the computer is paired to. We select connect, or we can disconnect. Right now it's connected, so we have a green light here. And then we have a next tab, which is the settings tab. We can calibrate the steering to make it into the straight position. We can also select the destination clearance for the GPS to stop when this destination has reached this number of feet. We can control the light settings. We can turn on or turn off the fog lights, the front lights, fog lights.
Hold on, let me look at the car.
Or the brake lights.
Okay.
So the fog lights could be off or on. The front lights could be off or on. The next tab we have is the car status tab. In this tab we show the sensor values, and we show the GPS data. This shows the speed in kilometers per hour. This shows the destination progress bar, the number of feet to this destination, the number of satellites that are tracked, and the GPS coordinates. Next we have the GPS tab. In GPS tab we can populate the locations that we specify in the programs from the database. Then we can choose any location that we have here. For example, if we select Burger King fountains.
Why don't you set it to that?
what we're gonna do is we can select dynamic path or without the dynamic path. Without the dynamic path, we set the destination, and the car will just go there. With the dynamic path, it will calculate the route through these points, through these known points, to get to that location. So if we set event center, and we are right now by Clark Building, it should go through the Burger King and Burger King fountains and to the event center. So right now it says that it's not at Clark yet, so it's going to go to Clark, then it's going to go to the Burger King fountains, and then it's going to go to the event center. So we have a total of 3 points. We can add, view, or remove known destinations. In the main tab, we have 3 modes. Free mode, which is just the obstacle avoidance mode. The GPS mode, so once the location is loaded, we select this mode and the car will navigate to that place. Or we have the manual mode, where we have the simple controls to navigate the car forward, left, right, and back. We can also select the speeds from slow, medium, fast, and our turbo fast speed.
Why don't you set it to medium and send it to Burger King fountain and show the progress bar?
So at this point, we're going to select the medium speed. We're going to see that to the Burger King fountains, we set the location.
Without dynamic?
With the dynamic path, it's going to go to Clark, then Burger King. We have 146 feet. So when I select GPS mode and I run the car, the progress bar will calculate and show how many feet are left to the destination. So at around 10 feet, the car will stop. Which it did.
Redo the same thing, bring it back here, and I'll record the car.
Sure.
Now, Albert, our audience, Albert, Pradeep, and Athawan, we're going to stand in the middle of the car, trying to block the paths. I'm going to look at the car and watch when how the signal is sent. Ready?
Right. 3 feet. Destination has reached. Ready?
So I want to at least demonstrate something. So we'll see.
Okay, now we're going to send it back to Clark. So
Take the speed.
go ahead. Can you pause it for a moment so I can catch up?
No. So beautiful. Sorry, we can't control the car. It drives by itself.
It's okay.
There's the Burger King.
That's Burger King location, that's why I slowed down.
And we have 170 feet left.
Now it's going straight to destination. Lights aren't blinking because now the speed is back up to medium.
go.
How many feet left? It's about
40. Right. 20 feet. 10 feet. Stopped.
That's good, that's good. It'll turn around really fast. So we're gonna set it to turbo speed now. See how it behaves.
Here, hold on a second. Show my little warning message.
So we're gonna set it to turbo speed right now.
Are you sure?
Yes. Of course.
115 feet. Put the car in the GPS mode. Select run.
Speed, what's the speed?
10. 15.
And it'll slow down by itself. Oh wow.
Break.
7 feet still.
That was oh, actually the turbo speed didn't kick in, because if it's less than 120 feet, it'll actually not go to turbo. Okay.
Oh, that's 20 miles an hour, dude.
Oh. Okay.
Oh, that's 20 miles an hour, dude.
Oh.
That's a cute little car. Where did you get it from?
We made it.
Oh, is it hard to make?
Yeah, it's navigates by itself, so it's hard to make.
Ready?
Oh, so you type where you wanted to go and listen to you? He said he likes he wanted a remote control car, but his brother likes to break it.
Okay.